Okay, we're going to deal with the last section of Chapter 9, so 9.5e, and we're going to do one last convergence or divergence test, and it's called the nth root test. Okay, so let's say we have a series of non-negative terms for all n greater than or equal to some n, where n is a positive integer. So basically, again, what this means here is that eventually you have to have a series of terms that are non-negative. If the first few are negative, that's okay. Okay, and we are going to suppose that the limit as n approaches infinity of the nth root of whatever your series is going to be L. Okay, so this is what we're going to base everything on. Then we have one of three things. If that limit that we calculate is less than 1, the series is going to converge. If that limit L is greater than 1, the series is going to diverge. And if L is equal to 1, the test fails and is inconclusive. So these three conditions here, where L is less than 1, greater than 1, or equal to 1, is very similar to the conditions for the ratio test. So hopefully that doesn't make it too hard to remember. The only thing that you really want to keep in mind of when you're using the nth root test is you probably don't want to use it unless you have something like an nth power. Because you can take the nth root of your general term, you probably won't want to do that unless it already has some sort of exponent that you are trying to get rid of. So let's take a look at a couple examples. This will be a short lesson for today. So let's say you have 4n minus 5 over 2n plus 1 all to the nth power. Notice that it is not a geometric series because we have n's on the inside, and because I notice that I have an nth power over here, I'm going to use the nth root test. So the nth root test says that we have to find the limit of the nth root of whatever your a sub n is. So that's going to go in here. So I'm going to write in 4n minus 5 over 2n plus 1 to the n power. So if you see, what happens is that the nth root and the nth power cancel, so that it leaves you with a much nicer little limit. We just have 4n minus 5 over 2n plus 1. Now when you're evaluating this limit, we're looking at the highest powers. The highest powers are n on top and n on the bottom, so our limit is simply going to be their coefficients, which equals to 2. And because 2 is greater than 1, the series diverges. Okay, let's take a look at a second example. We have 1 over ln of n plus 1 to the n power. So again, I notice that power, so I'm going to undo that by doing the nth root test. So I'll take the limit as n approaches infinity of the nth root of, again, whatever your series is. The nth root and the nth power will cancel, so that all we have left is 1 over ln of n plus 1. The natural log of n plus 1, that's growing and going to infinity. Your top has a constant value, so it's not growing at all. This limit is equal to 0, which is less than 1. Therefore, the series converges. So let's say we have 2 plus 2 over n to the n power. Going to have us again try the nth root test. Limit as n approaches infinity of the nth root of 2 plus 2 over n to the n. And hopefully you can tell pretty quickly that as n approaches infinity, this is going to equal to 2, because the 2 over n goes to 0, and the series diverges. Okay, this is a test that doesn't really get used very often because it's very specific. You have to have an nth power in order to take the nth root, and if you don't, you're just flat out not using the test. Okay, so pretty specific.